So this talk is about two programs that we offer in School of Mathematical and Computer Sciences and Department of Actuarial Mathematics and Statistics. These two programs are Actuarial Science and Statistical Data Science. And I named this as the power of data because many students and many people ask, what is the difference between actuarial science and data science? So the answer is both of them work with data. And both of them need data, they need to find data, they need to clean data, they need to build model with that data, and they need to interpret. And also they need to communicate their results. But the difference is the methodology that they use and where they use the data in order to solve problems. And we see later how this data is important and how the assumptions that we have is important when we want to interpret our data. So here we have Heriot-Watt personality. We transform people and their life. We want to make sure that we have global citizens. We expect our students and our graduates to be a global citizen, to respect diversity, and to be tolerant and use their skills in order to have the right impact on society and the environment. We have 5 campuses in Malaysia, Dubai, and Edinburgh. And our education is built on positive education philosophy, which means that we care about the well-being of our students and also the soft skills. It is important for us that our students learn how to have the right impact on environment and on the society. And this can be achieved through our Empower program. There are different levels and different clusters. One of them is global citizenship, as I just mentioned, and leadership and impact. So we have different workshops for our students in order to teach them how to lead. We have emotional intelligence, resilience, and happiness. We want our graduates to be a resilient people, to make sure that they know, to make sure that they are happy. Because happiness is not just based on what we have, it's based on our mindset. People skills, this is about communication skill. This is about soft skills, which is required by all employers. And this is something that they always tell us, make sure that your students know how to communicate. Creative innovation and entrepreneurship, we have different workshops for our students in order to teach them about entrepreneurship. And we had different competitions for our students as well. Critical thinking and decision-making, which is, I can say, the core part of a statistical data science program and actuarial science, and of course, many other programs at Heriot-Watt University. And employability and industrial relevance. So at the end of their graduation, at the end of their study, what the students can have is to have Empower Award, and they will have a degree to show their employers that this is what I had done when I was studying at university. Now the question is, who is an actuary and what they can do? So whenever we talk about actuary, in the past, because the traditional role of actuaries was working in life insurance companies. And in the past, whenever someone asked about actuaries, if they know something about them, they would say, these are people who work with deaf people. Well, they are not exactly working with deaf people, but they are working with deaf data. Those who want to price, for example, longevity risk. So when we say that they work in life insurance companies, it is important for them to build life tables, which means that they need to have data in order to predict the life expectancy of people in order to be able to set the premium, which is the price of life insurance product, in order to be able to determine reserve, in other words, how much money they need to set aside to make sure that they can pay the claims in the future. So for all this, mathematical skills is very important. and a lot of complicated and difficult formulae that everyone know about that. So they need to have this mathematical skills. You need to be good at math to be able to be a good actuary. Then they need to have analytical skills. So they need to be able to analyze data. As I mentioned, this is not just about actuaries, this is also about data scientists, because they have data, so what they want to do with this data. They need to be able to analyze data and communicate communication skills, which means that they need to be able to interpret their results and to communicate this. Because where actuaries are working, they need to be able to communicate with managers. And managers don't have anything about complicated formulae. Or, for example, they need to work with customers who don't have any knowledge about this mathematics, because they want to persuade them, okay, this fund is not the right fund for you, I mean investment fund, so it's better to invest in another fund. How they want to persuade their customers. So communication skills is very important. Some actuaries are senior actuaries, and some of them are in the board of directors. So they need to have management skills as well. And of course, they need to be creative and adaptable. So adaptation is very important because they need to adapt themselves to uncertainty in the future, uncertainty related to change in interest rate, change in financial market, inflation rate, and many other risks. For example, one of these risks is legislation. I was working with a group and we were writing a report, and I can say that every month we need to revise our reports. And the reason was that there was new requirement, we needed to update that, there was new legislation. And so that was just about our report, but actuaries who are actually working in a company, they need to adapt their practice. They need to adapt, for example, their formulae. For example, those who are working on the solvency and they build a model for the solvency of the companies, they need to make sure that they meet the requirements of Solvency II, which is a directive for them. And for example, this can be about tolerance level. It can be different risks that they need to take into account. So they need to adapt themselves, and this is important. But of course, they can impact on legislation because some of them are working for government, and in fact, they are governmental actuaries. So they are working in pension funds, and they need to find different reasons why we need to have different legislation. For example, there are some actuaries nowadays who are working on climate change. When we say that actuaries are working in climate change, that doesn't mean that they predict what happens in the future. They want to see what is the impact of climate change on life insurance companies, on general insurance companies, and how these companies can affect climate change. For example, do we need any legislation to persuade our companies that they don't have to invest in oil-producing companies, or those companies that produce a lot of CO2, and how it's possible for them to divest from these companies and invest in green energies, like solar energies. So they impact on legislation as well. They impact on people's life and business. Where do they work? Traditionally, life insurance companies, pension funds. Nowadays, they're working in health and care because, for example, they want to design different medical insurance, and they need to be able to have some knowledge about different diseases, different factors that affect these diseases, to build a model, to be able to set the price on these policies. So they work in health and care. And banking and finance, well, that's the financial sector, of course. Actuaries work in financial sector. They also work in technology because we have emerging risk. One of these risks is cyber risk. And they want to design a product to be able to offer. So what they need to do is to be able to whenever there is a risk, we want to know the cost of the risk. And how to find this cost of the risk? They need to build a model. They need to gather data. Sometimes this data is not available, but they need to use different sources to be able to build a model and to introduce a new policy. And as I mentioned, some actuaries nowadays work in climate change. We have different actuarial professional bodies, and including Malaysia, some of them provide different examinations. And here, and also you can get exemptions from these examinations through different universities, including Heriot-Watt universities. Institute and Faculty of Actuaries, IFA, is in UK. We have Society of Actuaries in US. We have Casualty Actuarial Society, again in US. We have Actuaries Institute in Australia. And for example, Institute of Actuaries of India, they all have different examinations. But when you become Fellow of Actuaries, they all recognize each other. The only difference is the practice, because, for example, if you want to work in Australia and you are Fellow of UK, IFOA, what you need to have is to have some knowledge about practice and legislation, local practice. So you need to perhaps have a training or maybe another course, but the most important thing is to pay money and to get the degree. It doesn't mean that you need to go through all those steps to become a fellow again. So they all recognize each other. And similar to any businesses, they need to develop. Actuaries also need to adopt different methods. So the question is, what does the future hold for actuaries? So let's hear from some actuaries what is the future of actuarial science and this business.
Technology is moving ahead far quicker than insurance companies are evolving. The industry has changed from doing a lot of nuts and bolts work in terms of maths to us actually analyzing the data and really being able to interpret what that means from an insurance company's perspective.
You can magnify so much information from data across the world, all the different sources of data. So it's about using that data in a scientific way for various purposes.
We've all seen the sort of Facebooks and Cambridge Analyticas and issues that brings up, but I think that there really is a high focus on professionalism from the Actuarial Society. It's really up to the actuaries to maintain that code of ethics and professionalism.
It seems to me that computers will automate more and more. Artificial intelligence, neural networks, cognitive reasoning will actually do a lot of the work which is currently done by actuaries. So in the fullness of time, it's going to be much, much more than maths. But I'm sure that emotional intelligence, intuition, and the sort of things that people don't necessarily associate with mathematics will be just as important. So you get that combination, that diversity will enrich what our profession can do.
I think we need to make sure that we are certainly more diverse as a profession, both in terms of skills and talents, but I think also in terms of backgrounds. Having said that, I think there's also an element of upskilling existing members and broadening the syllabus such that it sort of stays with the times, if you will.
We don't define what actuarial science is very well. If you ask 100 actuaries, you'll get 200 answers. And we need to do more thinking about what's that real unique added value.
The kind of traditional actuarial job is potentially going to be unrecognizable in some sense in, say, 20 years' time. The really cool thing is it's up to the new actuaries to really shape and drive that.
And these are IFOA examinations. So we have core principle. We have 7 subjects on the core principles. We have 3 subjects on the core practice, 2 subjects, specialist principles, and 1 subject. So there are a list of subjects, but you just need to choose 2 out of those subjects. And also 1 subject for specialist advanced. So this is the path to becoming an actuary. And here we provide exemptions for CM1, CM2, CS1, CS2, CB1, and CB2, which are under core principles. Here we have program structure. The first year is the same for both actuarial science and statistical data science. So sometimes we tell the students, don't worry if you are not sure whether whether to choose actuarial science or data science, because after 1 year, you still have this opportunity to switch from one program to another one. So the first year, you can get exemptions. So here we have some exemptions shown here by red color. So you can get exemptions from CM1 if you have actuarial and financial mathematics A and B. So one of them is in the first semester, the other one in the second semester, together with life insurance mathematics, again A and B, which is in second year. One of them is in the first semester and the other one is in the second semester. You can also get exemption, for example, by taking statistical models A and B, and and also probability and statistics A and B. So 4 courses is equivalent to one of the exemptions. And then we have portfolio theory and asset models. We have derivative markets and discrete time finance. These are all about CM2. We have also continuous time finance. So there are a lot of financial courses. In fact, we can say that the difference between actuarial science and data science, as I mentioned, is about the area that they use their knowledge. And if I have some students, they say that I don't want to hear anything about money. I don't want to hear anything about a stock exchange. So what I need to do, I would say, okay, go and study data science. But if you're interested in derivative market, if you're interested in finance, go for actuarial science. So I think that's the difference between actuarial science and data science. And data science is more towards computer programming and computer science than actuarial science. And yeah, you can get exemption from CS2 by taking risk theory, time series, and also here we have stochastic processes and survival models. And of course, when I say that you can get exemptions, that means you need to have a very good performance in exam. That's our condition. And this is entry requirements for English. And also, we accept ABB, and it is important that A is in math. However, we consider special cases, and this should be discussed in a committee. So don't worry if you don't meet these requirements, just send us. We need to consider those special cases. What our students say? Here we have Charmaine, who graduated in 2019. She was very happy for studying at Heriot-Watt University in Malaysia because she thinks that she didn't need to go other countries and she can stay here and still she can get an international degree. So she was a very good student, actually. Now, who is a data scientist and what they do? So data scientists also, they want to solve problems, but perhaps different type of problems. Their problems is not necessarily related to financial problems. They still need to have data. Sometimes there is not just one source of data. There are different sources of data, and they need to combine this data. And what is important is to look at the historical data and see and detect the patterns, to uncover any patterns and trends to be able to predict future. Of course, sometimes we say that past is not a good representative of the future. Data cleaning, as I mentioned, there are different sources of data, so they need to combine this, and data cleaning is very important. They need to build model using, for example, different computer programming like R and Python that we teach our students here. They need to be able to analyze data using different visualization tools. They need to check validity of their results. Of course, they need to be creative, and communication skills, again, is very important. As I mentioned, this is soft skills. Whenever you work on something, whenever you do some research, what you need to do is to communicate your results, because otherwise, what is the benefit of your findings? So communication is very important, and it is important to be able to communicate in simple terms, because sometimes people don't understand mathematics or even programming, the codes behind what you found. Analytical skills, again, is very important. Predictive analysis. Some of the actuaries now working in general insurance companies. So I know this is about data scientists, but some of them are working in general insurance companies. And as I mentioned, they started to adopt different methodology used in data science. And the reason is that they need to be able to predict, for example, the number of claims, the severity of claims, especially this is the case in general insurance company, because the product cycle is reversed. In the case of general insurance companies, in different manufacturing companies, we know the cost of raw materials, we know the cost of labor, and then we determine the price. And then we sell it to the customers. But in insurance companies, this is not the case. We don't know what is the cost in the future. This is something that we need to be able to predict. We just, based on our prediction, based on our assumption, we set the price and then we sell it to customers, which are policyholders. But we don't know about the actual cost that may happen in the future. So we need to be able to predict. And as I mentioned, nowadays, for example, there are different task forces in Casualty of Actuarial Society. I'm also part of that task force. We try to identify different potential areas in actuarial science that we can apply machine learning techniques. So these are not the type of techniques which are necessarily new. These are the techniques that it was not possible to be used in the past because extensive programming required, because we needed to have high-speed computers, but these are available now. So now we can adopt machine learning techniques and those techniques which require a lot of time and are time-consuming. And for example, one area that data scientists are working, they want to optimize processes. They're working in a company, and let's say the turnover rate in a company is very high. So they want to know what the actual reason is. Is it because of the pay? Is it because of, for example, the managers? And is it because of the workload? So they need to have data to analyze this data and find a pattern to be able to identify the problems and help the company to optimize their practice. So for data science, these are the skills that they need. Again, statistical skills, mathematical skills, these are similar to actuaries. They need to know computer programming, similar to actuaries, but of course this is more related to computer science, as I mentioned. So here we don't have data science, but we have statistical data science. So that's why most of our programs are about mathematics and statistics, because this is very important for the students to have this knowledge and to build their understanding based on statistical and mathematical skills to be able to build model. So that's why it is called a statistical data science, not just data science. And of course, machine learning techniques is something new to data scientists, and this is something that they need to know. Now, I was talking of the power of data and how it is important that we consider our assumption, how it is important that we interpret our results carefully. So this is one of the findings during pandemic. There is a negative association between COVID-19 severity and smoking cigarettes. Do you think it's true? It is in fact true, because this is published by European Commission review. So this is absolutely true, but it doesn't make sense. You know, COVID-19 is a disease that affects our respiratory system. And of course, those who smoke a lot, they don't have a very strong respiratory system. How is it possible that there is a negative relationship between these two? Can you think of anything? So it goes back to our assumption and the population that we consider. If you consider the whole population, in fact, there is a positive association between daily smoke cigarettes and COVID-19 severity. But if you consider only hospitalized people, there is a negative relationship. Because during pandemics, there were a lot of people in hospitals that they were not necessarily smokers. So that's why there is a negative relationship between COVID-19 severity and daily smoke cigarettes. So assumption is important, and the way that we interpret data is very important. And that's why we are talking about power of data, because this will lead to different conclusions that perhaps it's not right for the society. So here we have John Taylor, who was the then president of IFOA, who is he's an actuary, but he's also a data scientist since, I can say, 10 years ago, 20 years ago. So let's hear from him what he thinks of data science.
When I first heard actuaries described as the original data scientists, it was a phrase I really liked, because I think it captures the essence of what actuaries have been doing for centuries now. If you look back at the origins of the profession, we were looking at what at the time were large data sets around longevity and trying to find the truth and the insight in there and then extrapolate into the future. So I think that's really the essence of what data scientists are trying to do, albeit the tools and techniques and the technology have moved on massively, but the fundamentals of trying to extract truth and insight from data and then use that to infer something about the future is fundamentally the same. Data science is very empowering for actuaries. Not only does it give them the ability to re-engineer what they do in traditional fields, but it gives them a platform to move into wider fields like ride-sharing apps, like climate change, and even agriculture. We've been so accustomed to dealing with data and getting commercial value out of it in our industries, whereas other industries that haven't been so accustomed to dealing with data are now being deluged with it and don't really quite appreciate how to get value out of it. And so bringing in a profession who's expert in dealing with that data and getting insight out of it is a tremendous opportunity for those industries. Even some of the most creative industries like advertising, I heard recently that the Mad Men of TV series are being replaced by the Math Men. The idea being, of course, that advertising is much more data-driven, about finding individual segments and offering bespoke propositions, far more analytical, and even actuaries are getting involved in that type of stuff. As professionals who are immersed in the business context and understanding the impact that companies can have with end users, I think actuaries are well placed to add value and utilise the insights that data scientists can generate. Most actuaries will be very familiar to working in multidisciplinary teams. They've done that for a long time, but I think increasingly they will do so alongside data scientists and technologists. And I think it's the blend of skills that will make those teams very powerful.
In fact, some of the actuarial bodies now started to introduce different paths for data science and different certificates. For example, IFOA introduced new certificate about data science, Casualty of Actuarial Society, and also Society of Actuaries. They have different paths for data science. So they also started to make sure that they develop and they renovate themselves. They upper skills, and they also adopt new techniques. Well, as I mentioned, they're not necessarily new techniques, but the techniques used by data scientists in their work. Now, a statistical data science at Heriot-Watt University. So this is our program structure. As I mentioned, year one is the same for both actuarial science and statistical data science students, or SDS students, as we call it. In year two, some of the subjects are the same, but for example, statistics for social science is offered as an optional course to actuarial science students, or Bayesian inference are offered as optional course to actuarial science students, but these two courses are compulsory for data science students. And in year three, we have one course, which is in fact two courses, which are exclusive for our SDS students. And this is in fact a statistical dissertation, one in the first semester and the other one in the second semester. We have different electives. So if you study data science and then you think that, okay, I still want to know a little bit about finance, that's fine. You can take these subjects as optional subjects. So we have portfolio theory, derivative markets. These are compulsory for actuarial sciences students, but is optional for data sciences students. We have data simulation and statistical special topics for our STSS students as well. But why Heriot-Watt University? Of course, it is accredited by the Royal Statistical Society. We have very good scholarships, Data Futures Scholarship. We offer 3 scholarships of 100% and 6 of 50% for our students. And we have student societies here. SAS is for actuarial sciences students. And SOLID, which is Society of Logical Interpretation of Data. So this is the name adopted by our students themselves. And this is a society for our STS students. And they have different events. They go and they have different visits. For example, here we have annual dinner. And they visited Great Eastern, AIA, Bank Negara, and Bursa Malaysia. And also we have IFOA awards, up to 5 winners a year from Heriot-Watt University in Malaysia. And on top of that, they can also win Sir Edward Johnston Prize, worth over 1,400. And here we have QR code. I don't know whether it works or not, but then you can get some idea about selection criteria. And if you have more information, you need more information, you are more than welcome to contact my colleague, Larry O'Brien, and Karin Chua from IFOA. We can take a photo, whatever you like. Okay, thank you so much. And I'm happy to take any questions. Maybe we can start from here and then go to our pigeonholes. Any question? No? Or what are the difference between the career prospects between actuarial science and data science? So they can, as I mentioned, they can work whenever, wherever they need to have to use data, to analyze data, to solve problems. But data scientists rarely work in financial sectors because they are not interested in financial sectors. And but actuaries are usually working in financial sectors, banks, insurance companies, pension funds, or investment companies, and consultancies, and some other new areas. How many electives can we take on the 3rd year of both statistical science and actuarial science? Each semester, we have only 4 subjects, including compulsory and electives. So it's just 4 subjects. You can, so do we have any compulsory? If we have any compulsory, for example, in the 3rd year, because most of our optional courses are in the 3rd year. So if, for example, one of them is compulsory, that means you can have 3 optional courses. I've never done or learned coding before. Does the statistical data science requires coding? And if so, will I be able to cope with the lectures? Well, we're here to teach you coding, so don't worry. That's why you want to come to university. None of our students know how to code, but we teach you how to do this. So don't worry about that. This is our job to teach you. And of course, your job to learn. It's a two-way. I saw the content modules that both statistical science and material science had. They are very similar, I agree. So what makes them different? Is it the way lectures approach those topics? No, those courses which are compulsory for actuarial science are not compulsory. They are electives for data science, which are usually financial courses. That means we don't emphasize on financial courses for data science students. But there are some other courses, as I mentioned, statistical dissertation, which is exclusive for our data science students. There are some optional courses which are more suitable for data science students, not actuarial science students. I'm poor at math. Do I stand a chance at studying actuarial science? If you can meet our requirements, our entry requirements, you are welcome to apply. Otherwise, you need to be good at math, or if you say that I love math, but I'm not good at math, that means you are ready to study and to think that study is in fact your hobby. If this is your situation, you are welcome to apply, provided that you can meet the entry requirements. I know where most data science graduates from Heriot-Watt University work at which industry. Well, this year we have our first batch who are going to graduate, so I don't have any idea where they are working or where they will be working. But of course, there are a lot of different industries that they can work. There are different companies that they can work. So currently, I don't have any statistics, sorry. Are there any scholarships offered for actuarial science? I only see scholarship for data science. Perhaps this is a question our marketing team can answer. Of course, we have, for example, hardship scholarships, and we don't have a scholarship which is exclusive for actuarial science, but we have a scholarship which is exclusive to statistical data science. But we have hardship scholarships and other discount for actuarial science. You can get more information from marketing team. Can a data scientist work in a business company? Like, can he or she apply the knowledge of data science in business? Yes, of course. As I mentioned, for example, the turnover rate in the company is very high, and they want to see what the reason is that. For example, they want to see why a particular song is very popular in Spotify. What is the, I don't know, the properties of that song? This is another thing that data scientists are doing. So yes, they can use their knowledge in business because they can optimize different processes and also make sure that everything is working efficiently. And in order to see how it's possible to introduce different processes to make our practice more efficient, they need to have data, they need to analyze data, and to make some conclusions. How does the prospect of statistical data science compare to data science elsewhere? Okay, so statistical data science and data science, right. So data science, as I mentioned, is more about computer programming. So it has more courses in computer science, but we have courses in statistical modeling and mathematics. And this is the reason that we have a statistical data science, because we believe that if the students want to be able to build models, they need to have this knowledge. So that's the difference. And the prospect is different. It depends on, for example, if you want to work in computer industry, so data science is a better option. In fact, this is the program that we're going to offer in the future, which is data sciences, and this is more about computer science. But we're going to introduce more options related to computer science as well. Is there any certificate required to qualify as a data scientist? No. Our program is accredited by the Royal Society, Royal Statistical Society, so no, there is no certificate that you need to have, but as I mentioned, there are different, for example, actuarial bodies that they offer such a certificate. Will banks be willing to hire data scientists if he or she took all financial electives? Well, I can't make a decision on behalf of banks. It depends on your skills and how you can present yourself and your performance in financial courses. Obviously, data scientists can work in financial sectors as well. It depends on your preference. But if you can present yourself in the right way, and also you have a good knowledge in financial sector, why not? You can, of course, work in banks and any other financial sectors. As I mentioned, cyber risk is one of the emerging risks that actuaries are trying to work in. But perhaps data scientists with their knowledge in computer are better positioned to work in cyber risk or, for example, artificial intelligence and those things. Because, for example, they can introduce different methods in order to automate different parts of the business. Or, for example, so there are different ways that they can contribute to financial sectors. For example, they can work in, the credit part of banks or financial sectors, e-business, e-banks. Are degree holders for actuarial science considered a qualified actuary? No, I'm sorry. They are not qualified actuaries until they become associate or a fellow. So no, sorry. So we call them semi-qualified, okay, not fully qualified. Do we learn programming skills like Python or R or even data visualization, statistical data science? Of course we learn. And if so, may I know, do we learn the basics only or in depth? Thank you. So what do you mean by learning in depth? So this is the program that we offer. And of course, we need to teach you these are skills because these are the skills that all data scientists must have. But I don't know exactly what you mean by learning in depth because so we're talking about lifelong learning. So that means even after your graduation, there are a lot of new things that you need to learn. So still, we need to go for training to learn new models, new programming skills. So how deep you mean, I really don't understand because you learn the basics, of course, and you learn more than basics. The basics is just the first year, but then you go to the second year and third year, which are advanced level. And I can assure you that you will be a very qualified and employable person after your graduation. So don't worry about it. Is statistical data science very hard? It's not easy, and I think nothing is easy. For example, for me, but I think it depends on people. If someone tells me that you need to go and study literature, I think that it's a very difficult subject for me. Okay, so it depends on you, whether you are happy with coding, because there are a lot of computer programming, whether you like work with data, whether you like visualizing data, whether you like to communicate your results with others. So are you interested in these skills? If you are interested in these skills, no. I would say no, because if we are interested in something and we are ready to spend our time working on that and learn on that, we will enjoy that one. And this will become our hobby. So it will not be boring and it will not be difficult for us. So that's my answer. If you like that, no, it will not be hard for you. I know the difference of actuarial science and data science. As I mentioned, both are working with data, so there is a lot of overlap. Perhaps data science, we can say that it's more about computer science, and actuarial science is more about financial sectors. if you are interested in financial sectors and you want to work in banks, it's better to study actuarial science. Because if you study actuarial science, you will get some information about economics. And this is something that you need to know to be able to work in financial sectors, because you need to know about, what can I say, different, for example, macroeconomics, macroeconomics, and how banks are working. This is something that you need to know. In that case, go and study actuarial science. If you're not interested in financial sectors, and this is not something that you have in your mind, go and study actuarial science and, data science. And after that, perhaps you can work in, Microsoft, Google, and these companies. With COVID-19, will fresh graduates from actuarial and data sciences have a lot of trouble finding employment? Well, unfortunately, this is the problem for every programs, every industry. It's not just about actuarial science and data science, but we try to help our students to make sure that they are employable. Last summer, what we did, we introduced our students to different internship, which was online internship and provided by Casualty of Actuaries. So still, there are different options and opportunities for both actuarial science and data science students. But this is the problem that every industry are facing, and this is not just about actuarial science and data science. I know where most actuarial science graduates are working right now. Insurance companies. I have that statistics. Insurance companies. Any questions? So, sorry?
I see that there are a few questions that will be coming soon.
Oh, okay. So, is the credit of the statistical data science transferable to other universities? So you mean you want to study 2 years here and then go to another university for the last year? I didn't understand this question. If that's the case, you need to ask other universities. And, or perhaps if you are referring to the credit of your degree for example, master's and PhD, yes, of course. And our students, because here we have 3 years, and this is in fact an honors degree. So our students can go for PhD directly. They don't need to study master's. If this is what you mean. If you mean that, for example, you study here 1 year and then go to another university for the next 2 years, sorry, I don't have that information. I think it depends on that university. Is there a training program for actuarial science and data science? For example, 2 years in Malaysia and 1 year in UK. So it's not compulsory. Students can study the first year here and then go to, that's a Go Global program that we have. So some students study here, that the first year, and then they go to, for example, UK for the second year, and they again go back here to study the third year, or they study here the second year and then go for the third year to UK. That's called Go Global program. It's not the type of degree that we have here, because we have all examinations here. We have all, all the programs. The way that we deliver everything is the same as UK, and our exams are the same at the same time. All the study materials are the same, so everything is the same. And we don't have a degree that, for example, you need to study 1 year here and then go to UK for the next 2 years. That's not the case. That's an option for our students in order to gain a new experience while studying in another country. And that's a Go Global program that we have. So how many of you are interested in actuarial science? And how many in statistical data science? Perhaps first actuarial science? No one? A statistical data science? Oh, good. One.
Can I have a question?
Sure.
In my simple mind, after hearing what you have, the difference between actuarial science and data science, I seem to get an impression that actuarial science is more of like a specialist in the finance sector.
Yes.
And after the degree, and for those who wants to be, an associate or fellow of a professional actuarial body, they have to take those exams, right?
Yes.
Like IFOA and all that stuff. The degree from Heriot-Watt gives you like 6 exemptions,
Yes.
right? So, and for those who go all the way for actuarial science, they will become an actuary, most likely spend a lot of time, or their career will be more on the finance sector, in the insurance, maybe banks, but more insurance, I think,
Yes.
right? As for data science, is a buzzword for the last couple of years. It gave me the impression it's more generalist,
Yes.
right? They can go into many different industries
That's right.
that have volumes of data,
Yes.
and they apply statistical or math modeling in predicting trends.
Yes, exactly.
Is that?
Yes.
And for data science, it's not the same as actuarial, where you have a professional body is well established, many years.
Yeah.
Data scientists is, like I say, the new buzzword, right? So it's more generalist, and after that, how you grow from that is really up to the companies, the industry that you join, and how you apply your knowledge to help the company to grow. Is that?
Yes, that's right. And how you try to develop your knowledge. Yes, that's
so
right.
it's not associated with any professional body as of now.
No, but those students who also study the courses that we give them exemption from IFOA, they still can apply to get that exemption.
But they will not be, if you want to be a data scientist, I'm not sure, but it seems to me that people will not spend more time trying to get those few other exams to get a qualified IFOA associate member.
Yes, that's
Correct?
right. Yes.
Okay, thanks.
Okay, thank you. That's a very good summary. Thank you so much. Yes, that's absolutely correct. Do most employers want to hire qualified actuaries, or are they okay with just degree holders? Well, they are absolutely okay with just degree holders because they want to give you the opportunity to work with them, to learn from them, and also they they invest on you because most of them give you money and also time in order to study for your exams. So you have the skills and they want to invest on you. Yes, they are absolutely okay with degree holders. Of course, they will not give you the same salary, but they are happy.
What's the entry requirement for the statistical data science?
The same as actuarial science. Do we have a question? Oh, thank you. Okay.
Is it recorded?
I don't know. Is it recorded? I think it's live now, but
Yeah, it's live, but is it recorded?
yes.
You can do playback later. Is it?
Is it after master or PhD only could become a fellow of IFOA? It's in fact after your degree, but it depends how long it takes for you in order to pass the rest of the exam. So it can be after your PhD, after your master's. But if you study master's in actuarial science, you can get more exemption. So that's also a bonus. But it's up to you. For some people, it takes 2 years. For some people, it takes more than 10 years. For some people, it takes forever to become a fellow. So it depends on you. And would it normally take for a degree holder to pass the professional exams? As I mentioned, again, it depends on you how many exams you can pass in because we have 2 times per year. One of them is in the spring, another one is in autumn. And perhaps if you can take more than 2-3 exams in different diets, then that's fine. But some people may fail the exam. Some people need to just have 1 exam. So it can take 2 years. It can take more than 2 years. Is a statistical data science or data science easier to get a job? You can work in a broader industry when you study data science. But actuarial science, actuaries usually work in financial sectors, and financial sectors can be in different places, as I mentioned. So you can work in a broader industry. For example, there are even some data scientists who are working in some manufacturing companies, some pharmaceutical companies, because there are data analytics. So perhaps this is not necessarily the case for actuaries. As I mentioned, actuaries mostly work in financial sectors, but they also started to work in different sectors like climate change, and because their job is to find the risk and try to put a price on that risk. And there are emerging risks everywhere. So thank you so much for coming here, and thank you for your attention. Thank you for your question. Thank you for questions of our audiences at home. Please stay safe and good luck for your future.
Thank you.
Thank you.